Hello dear students, hope you are all doing fine. In this video, we are going to learn about how you can use the model builder for the geoprocessing analysis rather than the direct add data option. And this is very useful for any kind of analysis, not only geo analysis, to use the model builder because it will just work as a structure for your work. And using this model, by running this model, you can just make it or use it in different kind of for the different kind of layers and variables, so that in future it will be saved as a methodology or systematic diagram that will help you for the further analysis or any kind of moderation, any kind of advancement of the analysis. This is just like the background or basement, and using this model you can carry on your geoprocessing analysis very well. So in our last video we have seen that how you can select the potential sites for tourist resorts in the rural area of Kota Tinggi, which is a district of Malaysia, which is a tourist place, basically tourist district of Malaysia. So in this video, we are doing the same process with a little bit modification, and we'll show you how you can use this in an alternative way rather than directly using the add data. So let's start our process. So in order to do the analysis using model builder, you have to do some prerequisite work. You have to first open an ARC toolbox inside the folder where you will be saving your outputs, and then you have to open the model builder rather than just opening a random model from this model builder or geoprocessing model builder. So at first I'm just opening a new toolbox inside this connected folder physical planning, where my main shapefile land use data is stored. So I'm just opening new toolbox first, and then under this toolbox I'm opening new model. Here the dialog box or the model structure is prepared. You can drag all the required data, all the required layers or feature classes or shapefiles, and all the required analysis tool here. You have to do this manually and rather than just directly add data option. So I'm just doing the add data here and adding the main land use data file. Then our first task is to make the selection. In this aggregate shapefile data, we have to extract our required shapefiles or required fields from this land use data shapefile. Our required data, as far as you remember, or you can revise the previous lectures, that we need the water body field, we need the vacant land field, and we need the sea beach field to drag out and make it new layer. So in order to make a new layer, we have to use the toolbox selection first. You can type here the selection analysis tool in this search box. Otherwise, searching the selection analysis tool from the toolbox or searching any kind of analysis from the toolbox is quite time consuming. That's why rather than just searching it manually, you just type down here the selection and you'll find the selection analysis tool. There are lots of selection process. You have to find out your suitable selection tool, that is selection analysis that extract feature from an input feature class. So I'm grabbing here. This model is not prepared yet. We have to give the expression for the selection application to run. So our input feature class is land use data, land use RTD areas, and output feature class you can name it as water body because you will be selecting the water bodies, and here you can give the expressions, your required expression. Remember here the semasa, that is current land use, is termed and you will be selecting from the current land use field the water body. So the model is prepared, but it is not run or validated. So we have to run it or validate it You don't need to validate it now. Just put it run. If it is validated, then it is run without any kind of error. If the model is cannot run, then there will be an error. So the water body shapefile is created, but there is no result in the map. You can just right click on this option and just click add to display. Then your selected shapefiles will be shown here. Well, the water body's shapefile has been extracted from the land use RTD areas, but it is not selected or it is not saved as layer file yet. So you have to now apply the application from the toolbox, that is make feature layer. By applying this application, you can make this shape file of water body a different layer file so that you can easily work on this layer. So we are just applying the make feature layer application to make the water body feature class as a layer. So we are dragging this make feature layer option and our input feature would be water body. There is no expression needed, so we are just giving it OK, and we have to just run it. Water body layer is ready. So there is different layer over the main shapefile land use. Here one is water body shapefile and another is water body layer. At the same process, we have selected the sea beach shapefile from the land use areas. You can just simply copy the select option and paste here, and then reselect the shapefile and layer file, and we have make the sea beach shapefile as layer file. Now we have to select the vacant layer. So we are just copy the select option and paste here, and we have to change the expression. Our input feature class will be same, land use RTD areas. Output feature class will be save as vacant land, and we have to change the expression. The model is running for selection of the vacant land. So vacant land shapefile is created, and it is also shown in the map. And now we have to make the feature class as a layer. Now we will be doing some change from our previous ways. In the previous part, we have just chosen vacant land randomly, and we have chosen all the vacant land without any kind of selection process. But here, if you want to avoid some unnecessary steps, remember we have selected the criteria that the vacant land which will be chosen as potential vacant land for the resort, that must be greater than or equal to 1 hectare. The area should be greater, because otherwise the resort area won't be covered. So you can do this either way, by clipping it, or you can just apply the applications analysis tool later. But here I am selecting the vacant land layer class which are greater than or equal to 1 hectare in this process, in this first step, make feature class as layer. So we'll be giving some expression here. So expression should be Lua sector, that is the total area, greater than equal to 1. The layer is vacant land. Okay, so this model is run. Let's see the attribute file, that vacant land layer. Does it select? Yes. You see, the lower sector, I mean the area of the vacant land is totally selected, which are greater than or equal to 1 hectare. So all the vacant lands parcels which are less than 1 hectare are already excluded from the layer file, so that you don't need to just do some extra work later for selecting the potential vacant land. So our selection of the layer file is done. Okay, all of our selected shapefiles from the physical land use are ready as a layer file. Now we have to apply the basic geoprocessing tool. We will be starting applying the geoprocessing tool like buffer analysis, union, intersect, dissolve, merge, this kind of analysis. Our first step is to apply the buffer analysis, because in the selection criteria of rural areas tourist resort, there should be the tourist resort should be approximately within the 2 kilometer areas from the natural water bodies and within 3 kilometers area from the sea beach, so that the tourists can easily have the access to that natural places. That's why from our selected criteria, we are applying the buffer analysis over the water body layer and sea beach layer. So let's type the buffer analysis. You can also select the analysis from the toolbox, but it's easy to find it from the here. So buffer analysis tool we are applying on the water body layer. So our input feature class should be the water body layer, and the output feature class we must check on that we have to save the output feature class in our working folder, otherwise it will be saved on the C drive default geodatabase. Then you won't find it and you cannot connect it with your folder. It will be very problematic. That's why you must check on that you are saving this in the working folder. So I'm naming it water buffer and giving the criteria, selection criteria is within 2 kilometer area. See, the water buffer is ready. Let's add to display. Here the water buffer is done. If we just open the attribute table, we'll be seeing there are two new field here for the water buffer. There is a buffer zone. If you want to put the water layer over the water buffer zone, you can also do that, so that it will be easy for you to understand how this layer is prepared around the buffer zone. So next we will be applying the buffer analysis on the sea beach layer. Let's change the layer, and definitely check the output feature class will be saving here. It should be here. So we are naming it cbeach buffer. And the linear unit should be 3 kilometer because we said the criteria, the tourist spot, potential tourist spot areas should be within 3 kilometers from the sea beach. So you see the buffer is already done. And there is no need to put the buffer on vacant land layer because we will be not putting any buffer on the vacant land. We will be selecting the potential vacant land. But there are 2 or 3 more shapefiles that you need to buffer. Remember, we said that the potential tourist spots or the vacant lands should be within the 2 kilometer boundary of the roads, main roads, and the tourist spots and the rural settlements. So we have to apply the buffer analysis from the different folder. Here we have some other folders too. We have social land use and transportation. So we will be just selecting the shape files here and apply the buffer analysis. Next. We have add the data of rural settlement points from the social land use folder, and we have to apply the buffer analysis here. So let's apply the buffer analysis on rural settlement points. You have to just change the input feature class, not cbeach layer. You have to just input that rural settlements point and definitely change the output. We name it rural buffer. And linear unit, it should be within 2 kilometer buffer zone. So rural buffer is done. Now we have to apply another buffer on tourist spot points. Just change the input feature class and save it on the folder. Linear unit is same, 2 kilometer boundary. Tourist buffer is done also. Here is a point, tourist spot buffer. You can change the color, whatever you like. It will be easy for you to understand the difference. And you can also input the shape files here for your better understanding. Rural settlement and tourist spot. So you see there is a point features and there is a radius of 2 kilometer boundary that is made the buffer. And we have another shapefile from the transportation major roads because the potential tourist resort should be within the 2 kilometer boundary buffer zone from the major roads. So we are just add data of the major road shapefile. This is a line. This is a line shapefile, polyline, and we are applying the buffer analysis. We are naming the output feature as road buffer. our road buffer is done. If you just input the shapefile from here, you will see the buffer zone on the road network too. So there are lots of layers overlaid on each other, but these are not combined together. These are on different types of layers. They are separated. So our next task is to make them all together by applying the application called merge. We'll be applying the application merge here. Well, after the buffer analysis, we'll be applying the merge analysis because all the buffered layers are not merged or overlay all together. They are like saved as different feature classes. So we have to first apply the merge analysis and then dissolve them all together. But before that, we have to remember that in the buffer area, we have buffered different types of shapefiles like point features, polygon features, and polyline features. When they are buffered, they have been saved as a polygon feature because all the buffered zone are polygon features. So in order to merge them all together, you can just delete the field layer field from their attribute table. I have already deleted or removed the layer that is named as unknown polygon or unknown point features, and that is not required because we have already saved them as a polygon shapefile. So their previous introduction, the previous feature class is not important or not necessary here. So before merge altogether, you have to just remove the unnecessary fields from the attributes. So now we are applying the merge analysis tool. Let's select our input feature class, that water buffer, rural buffer, sea beach buffer, tourist buffer, rural buffer, and finally the road buffer. All the 5 feature classes. And then we have to save it as all merge. You can name whatever you like. Now the all merged is done. It is merged all the feature classes together. You don't need to just add this on the map. Now this buffer layer are all together as an attribute file. If you just add to the map, let's see the attribute table. They're all polygon shape files and they're all together merged. So water body, rural areas, they're all merged together. Now the application which will be applied here is dissolve. In merge, they have their separate identity, but when we dissolve them, they will be saved as a unique identity. So we are applying the dissolve tool from data management, not from the coverage. And we have to dissolve that all merge shapefile for our expected zone that we need for the analysis, or we need to get all the layer all together where we can just input our backend length layer. So for dissolve, you don't need to do much. You have to just put this all merge shapefile and then You are dissolving, save as all dissolve. You can dissolve on the field, but now I'm just skipping the parts. This is not compulsory. So we are dissolving all together. See, this is dissolve. Let's add to the display and see what happens to the shapefile attribute table. All dissolved. If we open the attribute table, they will get only a polygon shapefile. I mean, this place is altogether dissolved as a unique polygon or unique shapefile, because you just need to get the zone for input your expected vacant length. That's why we dissolve all the buffered layer and merged layer all together. Okay, let's uncheck them for our ease of work. Well, we have got our all dissolved shapefile, but we have to still do some work. We have to select our vacant lands in this all dissolved shapefile, because there are still some vacant lands which are not included in the boundary of the buffer zone. See, for example, all the vacant lands are not included in the buffer zone. There are still some vacant land which are beyond the boundary of the buffer zone, but we have to select the vacant lands which are included in the buffer zone only. That's why we have to apply the analysis that is called clip. We have to clip the features of vacant land from the all dissolved layer. Let's type clip. So clip analysis will be dragging here, and we have to clip our vacant land layer from the all dissolved layer. So our input feature class is all dissolved, and our clip layer should be the vacant land layer. We are saving this as potential vacant land. The clip is done. See, the potential vacant land are now included only in the boundary of our buffer zone, and the other vacant lands are excluded from the boundary. This is the potential vacant lands in which the rural tourist resorts can be constructed. The attribute table will show as only a polygon feature and combined polygon feature. Now you can do some kind of arrangement and presentation. You can add the selected layers, whatever you like to put in the map, and represent the map in a proper ways. In our next classes, we'll be seeing how you can just represent a map in a very presentable way with some kind of preparations like north sign scales and etc. You can input the other layers you need, like roads, network, water bodies, and the district map, whatever you want. Now you can save the model builder.
Our model is ready for analysis.